Hi guys, this is PHYZ Universal, and today we'll be talking about the Pythagorean Theorem. This theorem, as the way it is stated, that the square of the hypotenuse equals to the sum of the squares of the two sides of the right angle triangle. This theorem has got many real-life applications, right? From architecture and other things, but I'll be explaining those applications at the end of the videos, so please follow me from A to Z so that you can enjoy those real life applications and the reason why you should study the Pythagorean theorem. So now I'd like to remind you that you can like, comment and subscribe and press the notification bell for more tutorials that are going to come up in the PHYZ Universal. So now let's dive into it. So basically we have, well, a big square. We have the small square embedded in the big square, and we got four right angled triangle as it is seen there. And now let's name these edges of this square. So I'm going to name this side as A, this side as B, this side as C, and this side as D. And we're going to name this point, let's say this K, let's say this H, and let's name this as L, and let's name this as maybe V. That should be clear. And then we're going to name this side, I mean from A to K. Let's name this A, let's name this B, and we follow the same order: A B, A B, A B. So that's clear. Now let's go ahead and find the formula then. Basically we have to find the area of the three figures. Actually there are two figures because the first two are just squares and the second one just the right angle triangle. So let's find the area of the square ABCD. So the area of square, let me just use this, ABCD is basically, from this point, from point D to point A, this length is actually AB and is equal to all the ends, the lengths A, B, BC and DC, because the length of the square are always equal. So this is basically the length times the length. In this case, this is AB squared, or you can go ahead and expand it: A plus B, A plus B. So that's clear, and let's go ahead and use the quadratic identities, of which we know that A plus B squared is basically A squared plus twice AB plus B squared. You should know this by heart, right? Now let's drag this value to this point. Now we have A squared plus twice AB plus B squared. Now let's name this as equation 1. Alright, so here we have the first equation, which is this, well, the equation, the area of the big square, or the outside square. Now let's find the area of the four right angled triangle. So the area of the four right angled triangle, I'm going to choose the symbols, right, is definitely half the base multiplied by the height. In this case, the base, you can just decide to alternate. If the base is A, the height is B, and then you multiply by 4. Since there are 4, this is the first one, the second one, the third, and the fourth, right? So this is basically half of A multiplied by b multiplied by 4, since as I told you there are 4 right-angled triangles. So we can simplify this and we get twice AB. Now let's call this equation 2. I think at this point we're together and there's nothing wrong about this formula. Right. We haven't finished. We can still find the other area. Now let's find the area of the embedded square or the inside square. And in this case, I'm going to name this the embedded square, the shaded or the dotted square inside here as C. So all the lengths of this square, the inside square, is C. So the area of the dotted square is basically C squared. Now let us name this as equation 3. As I've told you, this formula is pretty simple. It's for you combining your mathematics skills. Right, so now we have 3 equations. Now we can go ahead and find the exact formula. And as I remind you, the formula that we're looking for is a squared plus b squared is equal to c squared. In this case, the square of the hypotenuse equals to the sum of the squares of the 2 sides of the right angle triangle. That's the formula we were looking for. So we should not get lost, alright? And then it turns out that the area of the entire square, or the area of square ABCD, is equal to the sum of the dotted square, or the square which is inside this big square, and the sum of the areas of these 4 right angled triangle. So now let's use that fact and prove the Pythagorean theorem. Now so the area of square ABCD equals to the sum of the area of 4 right angled triangles plus the area of a square, of a dotted square. Let me just put the dots just to make things clear. I think that's clear. This I just named this as a square, although it doesn't seem like a square. It's not drawn to scale, but you can just really understand it. Right, so as we've seen from equation 1, we've seen that the area of the big square, or the square ABCD, is nothing more than a squared plus twice AB plus b squared. Just from here, from equation 1. And then again, we've seen that the sum, well, the area of the 4 right angled triangles, I just forgot to put this sign. It is very important just to indicate the right angled triangle. So the area of the 4 right angled triangles, 1 2 3 4, is twice AB. Then we add the area of the embedded square, or the dotted square, as we've seen, is basically c squared. So at this point, this is clear. There's no need of naming as well equation, because first it is clear. Right, so we can cancel everything out of which we think are not suitable. Now we can take twice AB to the left side, and then we just cancel it out. So a squared plus twice ab minus twice ab plus b squared equals to c squared. As we can see that twice ab minus twice ab is basically 0. So a squared plus 0 plus b squared equals to c squared. Then we can simplify this as a squared plus b squared equals to c squared. I guess, guys, you know this formula and you've seen in many books. So that's how it was derived, and that's how you can prove that this is actually the Pythagorean theorem. It's pretty cool. It's very simple to derive. It's for you to combine your mathematical skills. So now, having seen the way we can derive this formula, now we can go ahead and look at the application of this formula. And in this case, I mean the real life application of the Pythagorean theorem. Now let's go to the next page and look at the real life application of this Pythagorean theorem. We should actually appreciate the Greek philosopher, the Pythagorean the Santos. He did very nice, interesting thing in mathematics, of which he used in architecture and in other big fields of mathematics. So now, without wasting your precious time, guys, let's take a moment and look at the real life applications of the Pythagorean theorem. Right, so I'm going to show you a few applications of the Pythagorean theorem, and the other one we're going to find the description below of the video. Just to keep things simple, I'll try to give you this scenario. Imagine we have 2 points. Let's say this point A and this point B, and let's say this is point C. I think you should follow me step by step, because the simple analogy which I'm going to use to explain the applications of the Pythagorean theorem. Now we are told to run from this point to this point to this point. I mean from point A to point B, then to point C. And then at this point C, this is the end of your race, and you are required to just run wherever you want to go, so long as you reach at point C, being the first one. So now, having studied the Pythagorean theorem, you can go ahead and run all the way from point A to point B to point C. You can use the Pythagorean theorem to find the shortest distance on the Earth's surface. Now we are told that from point A to point B is 4 kilometers, and from point B to point C is 5 kilometers. Right, and then if you have understood the Pythagorean theorem, which route are you going to take? Are you going to run from point A to point B, or all the way from point A to point B to point C, or you going to do something else? I guess if you have really understood the Pythagorean theorem, you're going to use the shortest distance. You're going to calculate the shortest distance to move from A to C. Now you're going to connect the line from A to C, and you're going to find your displacement. That's why we call it displacement, the shortest distance, because we believe that any point on the Earth's surface has got its shortcut way of reaching that point. So now let's say this person X has chosen this route. How many kilometers will you learn? Will he learn, or will they learn? Well, because it can be he or she. Will they learn? That's the inch that you should use. All right. Now let's say that this point, person X has decided to move from point A to point C. It has decided to ignore this long way, move from point A to point B, then point C. Now let's use our Pythagorean theorem. Remember, the Pythagorean theorem states that, well, the sum of the two sides of the right angle triangles equals to the square of the hypotenuse, or the sum of the squares of the two sides of the right angle triangle equals to the square of the hypotenuse. So now let's find this length. Let's call this C, and let's call this A, and let's call this B. Right, so we have A, we got B, we don't have C, so we find the missing side, and that's one of the applications. Find the missing side of any right angle triangle. Get it? So we have A squared plus B squared equals to C squared. Then we have A as 4 kilometers, so A squared, this is 4 squared plus 5 squared equals to C squared. We can go ahead and do the mathematics. So we have 16 plus 25 equals to C squared. Now we can go ahead and do the entire thing. Right, so we have, so C squared equals to, well, equals to 16 plus 25. What do you think would be that? What do you think would be 16 plus 25? That'll be 41. This would be basically 41. Right, so C squared equals 41. Right, so C squared, or you can just can apply the square root in both sides, then we remain with C equals the square root of 41. Now you see that this will be pretty simple. For the someone who will take this load from point A to point C, we actually take a very short distance compared to someone who will run all the way to from A to B, then from B to C. This guy is going to take 9 kilometers, while this guy is going to take less kilometers, almost 6 point something, because it be 6 point something, right? Right, so we can say that you can use the Pythagorean theorem to find the shortest distance on the Earth's surface. So that's one of the real life application of the Pythagorean theorem. Of course, another application is you can apply the application of the Pythagorean theorem in finding, well, the height of buildings. All right. Now imagine we have a certain building, or a story building. In this case, I'm just going to draw this, and then we need to find the strength. So this is the Earth's surface, all right, and then we're going to put our stepped ladder. This doesn't look as the stepped ladder, but it actually is. So our stepped ladder, I'm going to assume this is our stepped ladder, and then we're told that from this point to this point is basically let's say 3 kilometers. And the step ladder, just start the length of, oh, let's say meters. Kilometer is quite big. Let's say 3 meters, and this step ladder is a 5 meters. And then we can go ahead and find the height of this tower. Quite simple. Let's say this is the height we're looking for. We can go ahead and use our Pythagorean theorem and find the height of this tower. So basically we know that a squared plus b squared equals to c squared. Let's say that this is a, this b, and this is height, and the height equal, well, this is c. That's basically this is c, this is a, and let's say this is h. That's what we're looking for. Or we can just say this is b, but I'm going to use h since this is the height. Alright, so we have 3 squared plus b squared equals to 5 squared. Right, and then we know that b, I just named that h, so we can just do like this. So 3 squared plus h squared equals to 5 squared. So 3 squared is basically 9, and h squared is h squared. This is 25, right? So h squared equals 25 minus 9, and 25 minus 9 is basically 16. Then we can go ahead and square this. So we apply the square root here and there. So h is basically 4 meters. So the height of the tower is 4 meters. So the height of the tower is 4 meters. So now we can be able to find the height of the tower using the Pythagorean theorem. Of course, you can go ahead and use the trigonometric ratio to find the height of the tower if you know the length. Here is pretty simple so long as you combine your mathematical skills. Alright, so now this is how we can derive the Pythagorean theorem, and these are a few real life applications of the Pythagorean theorem. So for more awesome stuffs and more videos that I've made, you can go in the description below and find those videos. So now I say bye bye, see you in the next time.